Lesson 3, Venn Diagrams, Part 1. I've already introduced you to Venn diagrams in the first two lessons, but we're now going to look at them a little bit more formally and use them to solve problems. So let's start by recalling the following two sets. Set A, the natural numbers less than 20 that are divisible by 3, and set B, the natural numbers less than 20 that are divisible by 5. Let's write out the following sets. The set A intersect B would be the single element 15, as it is the only one in both sets. A prime intersect B prime would be those elements that are in neither A prime and neither in A or in B. Those would be 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, and 19. A intersect B prime, those elements in A but not in B, would be 3, 6, 9, 12, and 18. And A prime intersect B would be those elements in B but not in A. So that would be 5 and 10. So the relationship between set A and set B and the universal set U can be illustrated visually in the Venn diagram. I'm going to have you place the numbers on the following Venn diagram. At this moment, if you would just pause the video, and then once these numbers are recorded, start it up again, and you can see the answer on the next slide. Here is the Venn diagram with all the elements correctly placed. Please notice the following points. The number divisible by 3 and 5, the 15, is located in the intersection or overlap of the two circles. The numbers divisible by 3 and not 5 are located in the circle for A, but not in the overlap area. The numbers divisible by 5 and not 3 are located in the circle for B, but not, again, in the overlap area. The numbers in the universal set that are not in set A or set B are located within the rectangle, but outside of the two circles. Example 1. In each of the following Venn diagrams, shade the region representing the given sets. A intersect B. Which region would this be? This would be the region that overlaps between set A and set B. Let's look at A prime intersect B prime. So these are the elements that are not in A and not in B. So this would be the region that is inside the rectangle but outside of the circles. A intersect B prime. This would be the elements that are in set A but not in set B. A prime intersect B would be those elements in B but not in A. Example 2. I have given you a Venn diagram with two subsets of P and Q. The elements are listed within the Venn diagram. So let's list the elements of P. That would be 1, 2, 8, 9, and 10. Now the elements of set Q. 1, 7, 10, and 29. P and Q would be the overlap area, so that would be the 1 and the 10. P or Q would be the elements that are in either P or in Q. So that would include 1, 2, 7, 8, 9, 10, and 29. The elements not in P would be 7, 16, and 29. Those not in Q would be 2, 8, 9, and 16. G, not P and not Q, would be just the element 16. For H, not in P or not in Q. So this would include everything but the overlap. So this would be the 2, 7, 8, 9, 16, and 29. For I, not P or Q, would just be the element 16. And for J, not bracket P and Q, would be 2, 7, 8, 9, 16, and 29. Now there's a bit of a pattern here. So for K, I want to know which two pairs of sets are identical. And if you notice, G and I both give us the element 16, and H and J both give us the elements 2, 7, 8, 9, 16, and 29. And if you can notice the pattern between the words for G and I and those for H and J. Venn diagrams can also be used to represent the number of elements in each set, and not the individual elements, as this next example will illustrate. Example 2. The diagram displays the number of students who are members of the Students' Council, which is set S, and the number of students who are on the yearbook committee, set Y. So how many students are on the Student Council? So that would be both the numbers in set S added together, the 12 and the 3, to give us 15. The number of students on both Student Council and the Yearbook Committee would just be the overlap area, so that would be 3 students. On the Yearbook Committee, but not on Student Council, would just be the 7 that is included in Y, but we would not include the 3. And on Student Council or the Yearbook Committee would be all 3 areas put together, which would be 22. We're going to turn this around a little bit. Now I'm going to just give you the blank Venn diagram, and then from the question we are going to fill in the missing numbers. So let's look at example 4. In a homeroom of 20 students, 15 take math, 12 take science, and 10 take math and science. We're going to show this information in the Venn diagram, and then answer the question, how many students take neither math nor science? So the best strategy for this is to start in the middle. And if you notice that there's 10 students that take math and science, we're going to put 10 in the overlap area. Now, set M must contain 15, but it already has 10 in there. So for just 10, we will just have 5 students. Similarly, the set S will contain a total of 12. So since we already have 10 in the overlap area, we must have 2 students in just S. The question told us that we had 20 students altogether, but at this point we only have 17 accounted for, the 5, the 10, and the 2. So we still need 3 more students. These 3 students will be in the universal set, but not in M or S, and that means 3 students took neither math nor science. Example 5. In a survey of 400 households, 285 had a personal video recorder, or a PVR, and 320 had multifunction printers. We'll call them MFPs. 63 households did not have either a PVR or an MFP. So, we're going to let P represent the set of the households with PVRs. We're going to let M represent the set of households with MFPs. And we're going to let X represent the number of households that have both PVRs and and MFPs. If you notice, we were not given that exact number, so we're going to represent it by X. And since usually the best strategy for this is starting in the middle, and we don't have that number, we're just going to mark X in the overlap. And we do know that 63 households have neither, so we can place that 63 in fairly quickly. Step B. Write an expression for the number of households who have a PVR and not an MFP. So this would be the number of people that are in set P but not in set M. We know that 285 households have a PVR. We already have X accounted for, so the expression is going to be 285 minus X. Similarly, for part C, we're going to do the same thing for M. We know there's 320 households that have the multifunction printer. X have already been accounted for, so the expression will be 320 minus X. Now we still need to know what the exact numbers are for just P, the overlap, and for those houses that just have the printers. So what we're going to do, we know there's 400 altogether, so we're going to add those three expressions. The 285 minus X, plus the 320 minus X, plus the X that is in the overlap, and the 63 people that have neither. This is now an algebraic equation, and we can solve now for X. And I've shown the equation here. Finally, we now know that X is 268. So now we can actually do the final calculations and find out that 285 minus the 268 is going to give us 17 households with just a PVR. Our X is, of course, 268. And the number of households with just the printer would be 320 minus 268, which would be 52.